Hello everyone and welcome to ABB RobotStudio tutorials. In this tutorial we explain how to write a simple program for moving the robot along a path that's shown over here. The path is represented by this yellow line and the program is given over here. This program is written by using the Rapid Programming Language. The Rapid Programming Language is a very powerful object-oriented programming language used to program ABB robots. And let's analyze quickly this program. So what's happening over here? Well, the movement of the robot is controlled by this command moveL, and we specify the end point. And this instruction over here, or better to say, the set of instructions that's called a procedure, models and moves the robot along the yellow path. Then, this procedure over here is called inside of a single iteration of this for loop. And this for loop is executed 10 times. That is, in every iteration of the for loop, the robot will start from this position. It will start here, it will approach the object, then it will move along one edge, another edge, it will close the triangle, and it will go back. And in this tutorial we explain how to model everything. That is, first of all, we will explain how to manually define this path and how to write this program. So let's immediately start. Once you open RobotStudio, you will see this main screen. If you cannot see this main screen, you need to click on New, then on Project, and over here don't click on Include a Robot and Virtual Controller. We will add them manually later on. So click on Create, and this will create our empty workspace. Here it is. The next step is to add our robot model. So click here on ABB Library and click on IRB 120. And click on OK. So here is our ABB robot. Next, let's quickly learn how to zoom, rotate, and pan the view. To zoom the view, simply roll your middle mouse button forward and backward, or you can also zoom by pressing the middle mouse button and by moving the mouse cursor left or right. Then, to zoom, press and hold Ctrl, Shift, and the left mouse button and move the mouse pointer. Then, to pan the view, press and hold Ctrl, press the left mouse button and move left and right. Okay, the next step is to add an end effector, or a gripper or a tool. To do that, click on Import Library, and over here, click on Training Objects and click on Pen. Of course, you can add some other end effector, for example, Smart Gripper, you can also add. However, let's go back to Training Objects, Pen, and where is our pen? Well, here it is. You can only see the top of the pen. This is because it's being hidden by a robot and placed over here at the center of the base coordinate system. To attach the pen to the robot, do the right click on the pen and click on Attach To, and select Robot and click on Yes. And voila, magic happens. It's attached to our robot. So let's rotate and let's see the robot. The next step is to add the virtual controller. To add the virtual controller, click here and click on from Layout, choose the default option, Next, Next, Wait, and Finish. Over here you need to be patient, since you need to wait for this status to become green. Okay, so let's wait. This will take some time, connecting, and here it is. Now the virtual controller is attached to our robot and we can move the robot. The next step is to model our work object. Next, let's add a box or a cube representing our work object. So click on Modeling, click on Solid, and click on Box. And here is our box. Let's select these points. Here it will be 400, here it will be minus 150, then the length will be 300, and you can see how the box is already being formed. And let's choose the height. Let's see, for example, 500, is this too much? Let me rotate the view. It's too much. So let's see what if we specify here 400. Yeah, 400 is not bad. Right. We can select the height to be 400 and click on create. So here's our box. Close this box window and let's change the color of the box. So to change the color of the box, simply do the right click and modify. You can, for example, click on set color and let's choose this color and click OK. Good. Now we have our box. Looks very good. The next step is to define our path. The path will consist of a set of points. But before we even define the path, it's very important to adjust several things over here. So let's start. First of all, click here on Home, and once you click on Home, you will see that this menu is changed. And this is very important thing. We have to adjust this menu. So over here, Move L is the move command for programming our robot. And Move L means move linearly to the target point. Okay, so let's leave it as it is. Over here, speed is V1000. 1000 means 1000 millimeters per second. And this is too high value of the speed. Let's reduce this to 200 millimeters per second. And let's adjust this parameter. This parameter represents the accuracy or tolerance of approaching a point. Let's select it to be fine, such that we very accurately approach every point we define. Okay, now that we adjusted these things, let's start with defining the path. First of all, let's move a robot a little bit further from our work object. To do that, I will click over here on jog joint, then I will select this joint, and then I will simply press the left mouse button to move the robot a little bit away from our work object. Good. Let's start with the path. To define the path, first of all, you need to click over here, then you need to expand the controller, then you need to expand TROB1, and over here you need to click on Paths and Procedures. But before we define a path, let's explain the main idea. In this video tutorial, we will program the robot by first memorizing a set of points defining the path. So the idea is to move the robot and to do it manually to the corresponding points, then to memorize them, and then to add the movement instructions. By doing that, we will define a path in our program. And later on, we will edit that program further on in rapid programming language. This approach is called the teach method for programming the robot. Teach means over here that we teach the points. That is, we memorize the points by manually moving the robot. So let's start. To create the path, click here and click on Create Path. Then you'll see that this option is activated, Teach Instruction. If I now press the Teach Instruction, two things will happen. First of all, I'm going to memorize this particular point where my robot is currently at, or to be more precise, where the tip of the end effector is. And in addition to that, I will define a movement instruction to that point. So if I click here, look what will happen. Click on Yes. And if you expand over here, you will see the command. Move L means move linearly to target 10. And where is the target 10? The target 10 is actually this point over here. And you can see it over here by expanding this, this, and this, and you will see target 10. And here is the coordinate system for that target. Next, let's define the second point on the path. We should move the robot over here, that is to this edge of our work object. There are several approaches to do that. The most efficient and elegant approach is actually to define a work object coordinate system that will be attached to this edge and whose axes X and Y will be aligned with these edges, and then we can simply control the robot inside of the coordinate system attached to this work object. However, this will take me maybe 10 minutes to define such a work object coordinate system, and in the interest of time, I will do it manually. That is, I will manually move my robot by using snap tools, and then I will memorize the points. Okay, So let's start. First of all, we want to approach this edge. How to do that? Well, we need to move the robot. But before you do that, let's click over here on surface selection and let's click over here on snap edge. So now we turn the snapping tools. So if you now approach this edge, you will see this small sphere and you are able to select this edge. Next, let's move the robot. To move the robot, make sure that you are basically here in home, then click on move and rotate and select the end effector, and let's simply move along this blue line. This blue line represents the z-axis. So let's move down here. Okay, good. Next, let's move along this axis a little bit further, and you will see what happens. We immediately snapped to this surface, right? So we selected a point on this edge. Good. Now, to memorize this point, simply click here on Teach Instruction and click on Yes. Okay. Let's now go to Paths and Targets, and over here you will see Move Target 20. We defined two things. We defined the Move command and we defined Target 20. So let's now test this movement by clicking here, do the right click and click Move Along Path. And let's see what will happen. Good. Very good. We move to this path. Very good. Our next task is to define the third point on our path. And to do that, make sure that this option body selection is selected and click on the end effector. And let's try to move the end effector along this green arrow. At the same time, observe what's happening with this joint over here. So if I'm moving the end effector, you can see that this joint rotates for 90 degrees. So what's the issue with this? The issue with this is that this rotation might hit a singular point where you will not be able to move the robot due to the problem with inverse kinematics. Now, this is a very important thing, since if you memorize some point over here and if the robot twists itself, that is if the joints are in some weird position, you will not be able to move the robot. So it's always a good idea to manually later on adjust the position of these joints, and I will explain you how to do it later on. That is, if you now memorize this point and if you cannot move the robot, then you need to redo it by changing the orientation of some joints. However, I hope that this will not be the case right now. So I will move the robot all the way here at the edge, and then I will click on Teach Instruction and click on Yes to memorize this target and to create a moving instruction. And let's hope that this will work. Right click, then do Move Along Path. And let's hope that there will be no issues. Good, there is no issue. So we are lucky. Next, let's define the fourth point. The fourth point should be defined over here. So again, make sure that the end effector is selected, and let's start moving the robot along this edge. So let's move somewhere over here, okay? Let's memorize the point by clicking on Teach Instruction and click on Yes, and let's test the path. Right click, move along the path, and let's hope that we didn't hit any singularities. Perfect, we didn't. So it works. Now, what is the issue over here? We would like to move to this point over here, right? That is, we want to make a movement instruction to move to this point, and that's precisely actually the first moving instruction. That is, the first moving instruction is actually the second moving instruction is move to target 20, and this is very important. Okay, so let's do that. Click over here and then do Ctrl C to copy and do Ctrl V to paste and click on Yes. And here is the second instruction, and move it all the way down. Good. And you can see now that you close the path. You go from here, 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 and you can see that you have another branch or another line of your path, and this makes a triangle. And let's test this. Right click, move along path, and let's see what will happen. Do this, do this, do this, do this, do this, and you're here. And now we need to return to the initial point, and to do that, simply click over here, Control C, Control V, click on yes, and move this created point all the way down. And now we have the complete path. So again, click here, do the right click, move along the path, and let's see what will happen. Go here, go here, go here, 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 and go back. That's it. Perfect. We're all set. Now, we would like to generate a program that will repeat this 10 times. And of course, one approach would be to repeat the whole procedure 10 times. Copy and paste, copy and paste, copy and paste. However, this is cumbersome and not a good practice. The proper way for creating more complex programs is actually to use the rapid programming language. Okay, but before we can use rapid programming language, we need to transfer all these defined objects, targets, and move instructions to the rapid programming language. To do that, we need to click here on Synchronize and click on Synchronize to Rapid. This will bring you this menu, and you need to specify what you want to synchronize to Rapid. Synchronization to Rapid means that we will simply copy and paste all the defined points and instruction to the Rapid workspace, that is to our main file that you will see later on. So click over here and click over here and click on OK. Now, how to show the rapid program that models this? Well, there are several ways to do that. You need to click here on Rapid, and this will give you the Rapid menu. However, you don't see any program over here. To bring the program, expand Rapid, expand T-Robot1, and you can see the modules. Over here we have two modules, main and path 10. So what are the modules? For those of you who are familiar with programming, modules are actually functions. And this main module is actually your main function. So double click over here and you will see everything. Okay, so you will see your procedure main or module, that is procedure, functions, and modules are very similar. And here is our movement, right? Here's our movement that we just modeled, and it's modeled as a procedure. That is, you can see already that this is an object-oriented programming language. That is, all the motion is modeled as a procedure, and this procedure is called path 10, or it's simply a function. Now look what's happening at the beginning. You can see our points. So the points are defined like this. Here they are. Target 10, 20, 30, 40 copies of targets, and that's it, right? I'm not going to go into details, so these are the positions, orientations, and some other properties. And over here, you will see our main function. Okay, so the next thing to do is actually to bring our modeling window. That is our simulation window. To do that, click over here, do the right click, and click on New Vertical Tab Group. And now you can see at the same time your rapid code and your simulation environment. Now, what do we need to do here? We need to call our procedure over here. To call this procedure, we will simply copy and paste path 10, and then we will end the line. Don't forget to end the line. And over here, before you can run the program, you need to click on Apply and Apply Changes. This will save the changes such that you can run the program. To run the program, you simply need to click on Start, and let's see what will happen. And voila! You're currently running the rapid program, and you can see over here this pointer where your program currently is. So let's run it again. We are in the path, and then we go line by line inside of this procedure. We finish the procedure, and we are back here. That's it. Simple as that. Not a big deal. Now, let's write a loop that will execute this 10 times. So let's learn how to do that. Let's write the for loop. Over here, the for loop should look like this. For I is our iterator. Then we have from, starting from 1 to, for example, 10, do. Do what? Use capital letters, always, be careful here. Do path 10, that is execute path 10 10 times. And after that, let's just align it properly, we need to end for. Here it is. So this is our simple program. So what will happen over here, this loop will run, and in every iteration of this loop, we will call this function, or better to say this procedure, that will execute this motion. So let's click on apply, apply changes, and let's click on start, and let's see. Okay, so this is the first execution. Then we have the second one. Then we have the third one, etc. Simple as that, not a big deal. Okay, that's all for today.